Hello everyone, I'm Nianlong from Institute of Software, Chinese Academy of Sciences. The topic of my report is Get Grip, evaluating grip gestures for VR input using a lightweight pen. Virtual reality is emerging as the next generation computing platform for a diverse set of domains, including data analysis, artistic creation, and clinical settings. All of these require high-precision input. Current design of handheld controllers, such as the HTC Vive and Oculus Rift, typically include haptic and touch-sensitive controls, allowing users to launch continuous and discrete commands or movements in the virtual environment. However, these controllers primarily exploit wrist rotation gestures, missing the opportunity to fully utilize the finger's capability. In our life, it is an inherent ability to use the flexibility of fingers to operate tools, such as eating with chopsticks, throwing darts, and writing with a pen. When using pen as an input device, it can greatly utilize the flexibility of fingers while ensuring high-precision input. But we possess limited knowledge as to what extent pen controllers can benefit VR target pointing, selecting, and gesturing. To this end, we look into the potential of a pen-style controller and grip that can exploit the finger's rich dexterity for high-precision input in VR, and we conducted two studies to understand the use of a pen as an input controller in VR. The aim of the first study was to examine the effect of pen grip style and to identify the best-suited grip posture for a pen when trying to achieve the largest comfortable range of motion. Based on prior work, as well as those commonly used in art, we assessed a total of 5 grip postures. They are tripod grip at the front end of the shaft, tripod grip at the rear end of the shaft, quadrupod at the rear end of the shaft, pinch, and overhand. We used a 3D printed pen with 4 reflective markers, which were tracked by OptiTrack. We recorded the pen tip's spatial position and the pen's orientation information at every frame. A within-subject design was used, and the factors include 5 grip postures and 8 directions. In total, we have 4,320 trials. We calculated the Euclidean distance traveled by the pen tip and the angle tilted by the pen shaft. The participants were asked to complete NASA form to rate workload factors from 1 to 7 after the study. This is the process of Study 1. Participants were promoted to tilt the pen with a particular grip posture in 8 directions as far as they can without reaching discomfort. Results show that the moving distance with tripod rear end posture was significantly larger than all others. The tripod rear end posture led to a significantly larger tilt angle, except for quadrupod rear end. Across postures, the moving distance in the southwest direction was the largest, and the shortest distance was in the east direction. The tilt angle in the west direction was significantly larger than most of the directions, while the east direction led to a significantly smallest tilt angle except for the southeast. This is in line with our expectations, as all of participants were right-handed, with their actions appearing to be more flexible when tilting the wrist and fingers inwards rather than outwards. The NASA ratings showed that all grip postures were less than 3.5 except for quadrupod rear end. Some participants said that they had no experience in writing with Chinese brush. It's hard for them to use the couchpot rear end skillfully. The tripod rear end posture was rated as significantly easier to use than others. However, it is unclear how this grip posture would benefit typical VR interface tasks, such as target selection. Then we conducted study 2 to examine it. In this study, we aim to understand how efficient pen input is for VR target selection in comparison with the typical palm grip used in current commercial controllers. The study consists of 2 sessions corresponding to the 2 common interface gestures, poke and tilt, for menu and object selection tasks in commercial VR devices. Poke gestures are used to select items on menus that are physically reachable. Tilt gestures are often used alongside recasting for distant pointing. In each session, we use the within-subject design. The factors included 2 grip postures, pen grip and palm grip. Pen grip refers to the tripod rear-end grip posture in Study 1, and palm grip refers to the grip posture used in current commercial VR controllers. We set 2 levels of target width and 3 levels of target distance. This yielded 6 distinct face IDs. The selection time and error rates for poke were recorded. Participants were asked to complete NASA form after the study. In poke session, the action is identified by the pen entering the 3D target volume and then exiting it. In tilt session, we use the do-well trigger mechanism. The participants need to hold for 500 milliseconds to confirm the selection. The results show that the pen grip posture improved the target selection time with both poke and tilt gestures. The error rate of pen grip was significantly lower than palm grip in the poke condition. This law fitting well for tilt gesture. With increasing IDs, the pen grip selection is more efficient than palm grip. On the other hand, we didn't see a strong correlation with poke gestures, especially with palm grip. This might be because the pen overshoots the targets, as there was no physical surface that provides haptic feedback when using the poke gestures. The average NASA ratings for all grip postures were less than 3.5, and there was no significant effect between the 2 postures in poke and tilt. Though pen grip was faster in acquiring the target, some participants said that it did raise the fatigue issue. Then we presented 3 scenarios enabled by VR pen input and grip postures. It is easy to switch between the pen grip and palm grip postures. This enables new interaction opportunities. For example, one can select furniture with the palm grip and switch to the pen grip to invoke a menu and perform operations, like picking colors or adjusting skill values. With the pen grip, one can easily perform short and rapid input bursts, such as tilting and poking. These gestures can be used to trigger scrolling or zooming operations on a web view by tilting and poking the pen, respectively. Virtual pointing techniques, whose tool origin is located at the hand position, can suffer from the eye-hand visibility mismatch. The pen grip posture avoids this problem, as it keeps high consistency between the visibility of eyes and that of hands. We can see that there is a good potential to use the pen for VR operations in the future. Nonetheless, our paper has several limitations, some of which are worth exploration in future research. Firstly, besides tilting and poking gestures, The rolling gesture is also a variable input method in VR. One challenge of performing pen rolling gestures in air is to identify suitable grip postures that keep a good balance of range of motion and stabilization. Secondly, in our second study, do well was used to confirm a selection with tilt gestures and recasting. Designers could also add a physical button to the pen, but it raises a new challenge, that it is unclear how switching the fingers rules frequently would affect performance in pointing tasks. Thirdly, similar to most controllers, haptic feedback is critical for creating successful use experiences of the pen. Adding vibrotechnical feedback to the pen device is feasible with the high-frequency linear actuator. At last, despite the technical challenges, developers should aim for VR pen's form factors. Larger, heavier form factors may play a critical role in the user's experience. In conclusion, we look into the potential of a pen-style controller and grip that can exploit our fingers' rich dexterity for VR input. We found the tripod grip at the rear end is an optimal grip posture for a pen when trying to achieve the largest comfortable range of motion. This improved the target selection time with either poke or tilt gestures, and was less error-prone with poke gestures. We discussed potential interaction design and interaction opportunities with pen input in VR. Thank you for listening. If you have any questions, please contact my email.